Our first chapter is motion one dimension. When we refer to emotion in one dimension, we are talking about emotion that is restricted to a straight line, to a straight path, street, or road. This road or this street might be, or this straight line might be horizontal or vertical, or in general, any other oblique line or straight line. The most important is to have the road or the street as a straight line in order to collect motion in one dimension. However, for motions, for example, in a curve or in a circle, this is not a motion in one dimension. This is about the motion, this is about the one dimension. So the condition is that the body must be moving on a straight path, whether this is horizontal like this one, or vertical like this one, or in general any other oblique straight line. This was about the definition of one dimension. What do we mean by motion? What is the definition of motion? Or when a body is said to be in motion? A body is said to be in motion when it changes its position with time. So we can define motion as the change. So motion can be defined as the change in position as time passes, the change in position over time. The question is, what is position? What do we mean by position? Or how to determine, for example, the position of a body on a street. Let's consider that this straight line represents the street. Again, it is a straight line since it is motion in one dimension. And the car stopped down here, down the street, let's say here. If someone asks you about the position of your car and you just reply to him, it is, for example, 6 meters, 6 meters away, it would be an incomplete answer. Away from what? Away from you, away from a tree, to the right of a sign, to the left of another obvious mark. So we need an obvious mark or something which is obvious to everyone in order to compare this position to. So, for example, if you have a tree here or any obvious sign to everybody, let's say it is here. So now you can say that your car is, for example, 6 meters to the right of this sign or this tree or this any other obvious mark. 6 meters. This is called the position of your car. You can consider it as a position of your car, and this mark or this sign is called, which is very important in physics, is referred to as, this is called the reference. It is a very important concept in physics. I mean, in order to allocate the position, you need a reference. So this is can be taken as reference. Again, the reference should be obvious and known to everybody in order to be able to allocate your position. Here, this UCAM might be, this is to the right of the reference. In case your car is to the left of the reference, it might be here, for example. So to the left of the reference, we give it negative sign. So it is now, for example, minus. Let it be -4 meters. to the right of the sign, to the right of the reference, the value is positive. However, to the left of the reference, the value is negative. But usually we write it 6 without plus. In mathematics, the number without any sign preceding it means positive. Mathematically speaking, to convert all this, the road, the reference, the numbers, to convert all this into mathematical expressions, and this is one of the main targets of physics, is to convert natural phenomena or artificial phenomena. Um, in artificial phenomena, we mean the experiment. To convert all of these into mathematical expressions, uh, the street is designated as x-axis. So in mathematics, we usually use the street or the path is designated as x-axis, and the reference is designated as O, the origin. And the position of the car, which was, let's say, 6 meters, or any number, let's say 6 meters, for example, plus 6 meters. This is our position, and we use the expression, the mathematical expression, x1. The position is referred to x, this position is referred to x1 equals 6 meters. Now, if the car changes its position or its location to a different one, let's say to 10 meters, for example, to a new position, let's say here, which is the new position. Now, that's it, would be, for example, 10 meters. So if this is the first or initial position, this would be the second or the final position. Then the second position or the new position of the car would be x2 equal 10 meters. Then we conclude. So if your car initially was at 6 meters, then you find it, or somebody finds out that it takes a new position, which is 10 meters, this body will come to a conclusion that the car has moved. So now we can say, since the car changed its position, we can say that the car has moved. The car has moved. Therefore, we define the motion as change in position. So again, motion is simply the change in position with time. Again, in position with time or over time or as time passes. Let's move to a very important concept in physics, again, which is the distance or displacement. So it is now distance or displacement. Let's go back again to our example. Let's go back to our example, or let us write a question, uh, which is, for example, related to the previous car that we have seen. Find the distance. Let the example be. Find the distance or displacement or displacement that the car has moved, as it, changed its position changed its position from position x1 from its initial position or from position x1 to the second or the final position x2. Let's draw again our street, which is represented again as I have mentioned, which can be represented as a straight line in mathematics. So this is our street called x-axis. This is our reference O. So now we are talking about a car which was at 6 based on the question and then moved to 10 position. So this is x1 initial position relative to O, to the origin, to the reference. This would be x1, which is 6 meter. The second position after the car has moved is x2. x2 equals 10 meters. So it's very obvious that the car has moved by this distance. Sorry, from here to there, which is equivalent to 4 meters. It was at 6, then it becomes at 10. This means that it has moved by or displaced by 4 meters. This 4 meters is called the distance or the displacement. Again, changing this into mathematical expressions or equation. So we are going to write the following. Again, which is very important to know how to convert the phenomena into mathematics. So it would be written like this. The distance or the displacement delta x, or simply you can call it x, is equal to the difference between the two positions. It is equal to, so now first in the first uh, I'm going to write down this as in terms of words like this. Distance or displacement, distance or displacement is equal to the final position or the second position as you like, the final position minus 10 minus 6, the final position minus the initial position. So in terms of symbols, mathematically speaking, the distance we refer to as x, because we are talking about x-axis, horizontal axis. Distance or displacement, usual displacement is referred to as delta x. You have the option to use either x or delta x is equal to the final position or the second position is x2. So I'm going to write here x2 minus, this is the rule, initial position is x1 minus x1. Let us substitute the values, the given values. So x would be equal to x2 is 10, x2 is 10. I'm going to put here 10. And the rule says that we should have minus, while x1 is 6. 10 minus 6 equal 4 meters. And this is what we have just mentioned, that the car, the body, the object has moved through or by 4 meters. I'm going also to take another example. Let's consider another example. Let it be example, for example, let it be 1. So example 1. I think I should have call it 2.1. Sorry. So it would be 2.1. A car has moved from the position A to the position B as shown in the figure. So let's draw the figure which is given, sorry, as shown in the figure. So let me draw this figure. Again, let's consider the street, the horizontal street, as, as x-axis in order to be able to convert everything into mathematics. My reference, which might be a tree or a sign or any other thing, let it be O. So our position A, which is here can be considered as the initial position, is here. The car was here. To the left of O, if you remember, I have mentioned that to the left of the origin or the reference, the values are negative. So this would be minus, let it be, for example, minus 5 meters. So this is position A. The car would move to a position B, which is about, oh, let us say 7 meters. So this distance is 7 meters. This is position B. Again, this means that the car has moved from position A to position B, from the initial position A to the position or the final position B. It is required to find the distance. So it is required to find the distance through which the car has moved, or that the car has moved. Sorry. So find the distance that the car has moved. Again, let's apply the mathematical formula, but let's first write down the given. The given is that the initial position, which is x1, or you can call it xa. You can call it x1 or xa, but you have to keep in mind that it is the initial position, xa or x1 as you prefer. We can call it x1. No, it is the same, or x1, that I mean, which I mean the initial position, is minus 5 meters. The new position or the final position, xp or x2, is 7 meters. So we need to find the displacement of the distance, x. It is required to find x or the displacement. Again, simply let's apply the formula or the mathematical formula or the rule, which is x equals x2 minus x1. Let us substitute. X equals x2 is 7. So x2 is 7. So it is 7. And minus is included in the rule. So keep it down. Minus x1 is minus 5. So we it is good to use the brackets. So x1 is minus 5. Minus 5. This minus is from the rule. The rule includes the minus sign, the negative sign. But this one is from the value of x1, which is to the left, since it is to the left of the origin of the reference. So now x would be equals to 7 Minus minus in mathematics, minus minus followed or minus two successive minus sign is equivalent or becomes plus. So this is from algebra. Minus minus is equal to plus. So we replace the two minus signs by plus 5. 7 plus 5, it would be 12 meters. This means that or the car has moved by 12 meters.